Uh, Welcome to the second day of our NSF ASEAN workshop. We had a really successful day yesterday. We're looking forward to our half day today, starting with our keynote speaker today. And I'll first just say a couple, we'll basically have our keynote, and then we have a panel discussion after that, building on the breakouts from yesterday. So, yeah, it's a great pleasure to introduce our keynote speaker today, Julius Knapp, who is the chief of the FCC's Office of Engineering and Technology. OET is the Commission's primary resource for engineering expertise and provides technical support with the chairman, commissioners, FCC bureaus, and officers. Mr. Knapp has been with the FCC for 42 years. He became chief of OET in 2006. Previously served as the deputy chief of OET from 2002 to 2006. Prior to that, he was the chief of the Policy and Rules Division, where he was responsible for FCC frequency allocation proceedings and for proceedings amending the FCC rules for unlicensed radio frequency devices. Okay, well, he's got lots of awards. He's an illustrious career. So, with that, we would love to hear more from you, and thank you so much for coming. Really appreciate it.
Good morning, everybody. I'm actually going to do a joint presentation with Walter Johnson. I know you're all experts on 5G already. How many of you were at GlobeCom? Everybody. Almost everybody. So I have some of the slides from GlobeCom, but I'm not going to spend much time on them. I'm just going to flag a couple of things that maybe I didn't mention in the keynote. It's focused on 5G, but the second half of this presentation is going to talk more about our experimental licensing program, which I think if you're going to do research, you really should be familiar with. So I talked about the core principles that we've applied. Key is flexibility. The FCC, with the exception of the first generation of wireless, we haven't specified standards. It's all been developed by the industry. Even in the first generation, amps at 800 megahertz, it was developed by industry. We just incorporated it by reference into our rules. So key point, there's not anything coming out of the FCC that's going to tell you exactly how the technology ought to work, and everything about how the networks operate is all done in the private sector. So last summer, we adopted rules that provided a huge amount of spectrum. And I'll also underscore, it wasn't identified as the 5G spectrum, even though we knew everybody would call it that. We started out calling it millimeter wave, even though technically that's at 30 gigahertz. We started everything above 24 gigs. And then we called it Spectrum Frontiers, but everybody thinks of it as the 5G proceeding. But really, the rules that we adopted would allow you to deploy just about anything. It could be used for fixed or mobile service. So people can develop the networks and the technologies and the applications that they think will best fit the market. And I also mentioned, so I know John Wilkins talked to you yesterday, went through all the details about the bands. You keep hearing us refer to 28, 37, 39 gigahertz. We adopted the full set of rules. There's the power limits. We specified the bandwidths for the licenses and so forth. So you kind of have a pretty good idea of the space each licensee will have to work in. And then we proposed a whole lot more spectrum, and we also proposed to open up the bands above 95 gigahertz. Sometimes we had adopted the rules for millimeter wave spectrum. Seems like it was at least 15 more years ago, and there wasn't a lot that happened. I think just in the last few years we had the wide gig standard that was adopted. So, when you adopt these provisions, it's like planting seeds. They don't sprout immediately necessarily. Sometimes it takes while for the technology to develop. So there's some work going on above 95 gigahertz. This, was really a part of the spectrum where there was very little, if anything, going on. So the fact that we've opened that up, again, it's a seed that encourages innovators to develop new technologies up there, and it might take years for it to develop into something, but we're trying to create that opportunity. So I also talked about what is 5G, and the only slide I'm going to give on this is you hear folks talking all the time about the data speeds and the reduced latency and the importance that the reduced latency has for real-time interactions, things like virtual reality, interaction with machines, and so forth. But what's a little bit different here than I think in the prior generations is there's much more focused attention on market sectors, transportation, energy, and so forth, and how the reduced latency could open the door to new applications there. So when we start talking about things like smart cities, and the idea of smart cities has been around for a while, and we start talking about applications like, vehicle to vehicle and vehicle to infrastructure, you have to start thinking about, how exactly is that going to work? How are you going to take advantage of that reduced latency if you're talking about things that are going to communicate at the upper reaches of the spectrum, where there really hasn't been a lot of work done on two things moving and how they will be able to reliably communicate. So, this was a detailed chart about the bands. There's just a couple of things that I wanted to flag here. Every one of these has the idea of sharing somehow embedded in it. Every one of these bands had a different set of characteristics. So at 28, there were two issues. One is we had already got deployed point-to-point microwave systems. And so what we did there is basically we gave those licensees the right to deploy mobile. So market mechanisms were introduced. We didn't take them and displace them. We said you've got more flexibility. You can have let the market work out with business deals if you want to deploy mobile or fixed. The other thing we had in there is satellite uplinks. There's not a lot of the Earth stations, and when you work the numbers, the fact that you've got high-powered Earth stations transmitting upward really didn't take out a lot of holes from where you could offer service. The estimates vary, maybe 500 yards, something like that. And you can work around it because you have so many more bands to play with. So it doesn't mean there's no service in those areas. It's just you're going to deploy other resources in those spaces. The bigger issue there too, that what the satellite industry is worried about, and we did provide some room for additional Earth stations in each county, and so they've got room to grow on the uplinks, but they're worried about aggregate interference. And in the commission order, we explain why we don't anticipate that to be a significant issue. Yet we also opened up a docket to keep an eye on the studies that unfold. The difficulty you have is trying to predict exactly what is going to be deployed here. We know that the signals fall off very rapidly and that they're highly directional, that the path losses are going to be great. So intuitively, you would think this is not, and you're not trying to beam energy upwards. So intuitively, you don't really anticipate there's going to be a problem. But I know that at the same time, you say you don't know what it's going to be. If you're a satellite provider, that makes you anxious about exactly what's going to happen. And at 37, it was mostly a blank slate. But the issue there is it was also allocated for the federal government, for the Department of Defense, and they saw this as a resource that they might be able to use in the future. And so they wanted to be able to deploy things in the future. They don't know exactly what. So what we did, because it's a pretty, it's 1.6 gigs of spectrum. So we took 200 megs and we said, well, this is going to be DoD. and we said we'll share across maybe another 400. Specifically, we asked questions in a further notice about exactly how that sharing would work. And then we still wanted to explore about sharing across the whole band. So one of the things that gets lost, historically, the military has developed their own technology on separate paths. And, there's good reasons for that. But the technology we're talking about now is not plain old cell phones anymore. It's really a very versatile technology that can do just about anything except maybe radar. And so the fundamental and the pace of the investment in the technology is so vast that even when you invest in it domestically, just for military, it can't really keep up. It's all moving so quickly. So there are potential ways that the technology could be used for military applications as well. So one of the benefits here at 37 is if we can get everybody sharing a piece of the pie, everybody wins from potentially using the technology. And then at 39, once again, we had point-to-point microwave, but we also had folks who are contemplating deploying new broadband satellite systems in that spectrum. And so how can they share and under what conditions? So I just wanted to highlight a little bit about that, because when you start thinking about research and how the sharing is going to work, what sounds simple sometimes is a little bit more complicated. And I've often said, we're not doing sharing just because we want to do sharing. Is that, you'll often hear people say we've got the spectrum and only 10% of it is being used at any given instant in time. The challenge for us is how do we get more out of that? And if the sharing allows valuable use, for services in places that are meaningful, then it's a worthwhile investment in trying to figure out how to make that happen. And it doesn't, people hear sharing and sometimes they think it's synonymous with unlicensed. It isn't, because as long as we've got a sharing regime, we understand we can issue licenses and provide the certainty and the protection to those licensees, as long as it's not a lot of value to licensees to have space where they can share in the middle of nowhere because they're trying to provide service to people. So I talked about international harmonization. Just a few more words here. So there was a lot of discussion at the last World Radio Conference about 28 gigahertz. And the United States has led the way in allocating spectrum for mobile use at 28. The satellite industry has had a lot of concerns about that. It's not one of the bands that's on the list of bands to study for the World Radio Conference in 2019, but some other parts of the world are looking at spectrum that's adjacent to it. And the question then is, can you have a device that tunes across the band that's just lower to what we call 28 and have one device that would be capable from a design standpoint to operate across both. And everything we've heard so far indicates that that is possible. There are lots of benefits to having international harmonization, so you don't have to design multiple kinds of equipment and so forth. And then many of the other bands either align exactly or they're pretty close. So I think we're optimistic that after all is said and done, we'll have a set of allocations that will be harmonious. So again, some of the factors that enable a sharing: high amount of spectrum gives flexibility, high path loss, adaptive antenna technology, as well as massive MIMO and heterogeneous networks. So I'm just going to throw up a couple of things here. While you're here, the Advanced Wireless Research Initiative, which was announced the day after the Commission adopted its order, as a way to encourage investment in research on the fundamental technologies. I would distinguish that what we're doing here in the States is a bit different than the kind of R&D that I think some other parts of the world are looking at. I think in some other parts of the world it's really focused on let's specifically develop the 5G and we'll all get together and map it out, as opposed to What's going on here, I think, is research in the underlying wireless technologies and then trying to figure out how we use that in terms of applications. But it's a whole different philosophy, here for us. We've always been based on flexibility, letting the technology develop, not have it be driven as industrial policy. So I just thought I'd toss up here some ideas, because 5G is breaking new ground in so many areas. And there's research work in so many elements. This just was off the top of my head. The channel modeling, propagation, understanding, there's work going on. Okay, I can figure out free space path loss, but how does this stuff go through buildings made of bricks, made of sticks and wallboard, and so forth, and understanding that, because nobody really had been thinking. There are folks out there who are looking at this for fixed applications, but trying to understand how the propagation is going to play into applications involving mobile needs to be understood. What's the transmission format? What it was about the adaptive antennas, massive MIMO. I know there's a lot of work that's already been done on this. How does this play into the services and the applications, like I mentioned before? It's easy to say vehicle to vehicle, but exactly how does that work? Heterogeneous networks. We went from networks that played in 1 or 2 or 3 or 4 bands, and now we've got all of these different bands. How do you decide how you manage the resources? When do you do a handoff, for example, from one resource to another? Spectrum sharing, the things I talked about. This is just pulled down from the NSF website, talking about the funding opportunities for 5G research. And the whole idea here is creating test beds. And I am going to turn it over now to Walter Johnson, who heads our, it's a bit of a misnomer, it's EMC Analysis Division. What Walter's division does is basically all of the fundamental technical and analytical work, not only for my office, but for other parts of the agency as well. And his shop has got within it the experimental licensing branch. Usually what happens as people are developing new technologies, when you want to do things on the airwaves, they need to get an experimental license to do that. So Walter's going to tell you about that program and how it works, and some things you want to keep in mind depending on the type of research and the deployments we're looking at in the future. Okay.